Computer crashed, huh? That's probably what happened. But anyway, thank you, Emily. So we'll have a partial recording. How do I start this problem? I start it with our definition. The limit as h approaches 0, f of c plus h minus f of c all over h. And then, what do I plug in for my function?
Would it be 2x? Yeah.
It would be 2 square root of x. Great. I love it when we're talking over each other. I really do, because that means we're like multiple people just feel like they can just jump right in. It's exactly what I want this class to be like as soon as we can get it there. So great job. So we should say this is the same as the limit as h approaches 0 of 2 square root of x, right? Well, what are we going to plug in there for our first spot? If we want our function at f of c plus h, what should we plug in?
Would it be 9 plus h?
It would. It would be 9 plus h. How do we know it's 9 plus h? Well, we know it's always plus h, and we know that c is the value that we're trying to find our derivative at. Okay? Minus, what would be the next term, Aaron?
2 square root of 9.
Perfect. And then let's see, Michelle, what would be in the denominator?
The h.
That's an h. And now I see, hey, can I simplify it all? I bet I can simplify this last term. Usually I can. What's the square root of 9?
3.
And what's 3 times 2?
6.
Okay. And so this is where this gets hard. What happens when we try to go backwards? What if I asked you, what if I told you, hey, the limit as h approaches 0 of 2 square root of 9 plus h minus 6 all over h is a derivative? Would you be able to tell me what function it was the derivative of? Hopefully, but it might take a while because this part, this yellow part, might mess you up. But if we can realize, hey, this is really just f of 9, and I have to figure out what the function is, that would sort of help me. And so what I'm driving at is I want us to look at this next one in our list. We have the limit, we're looking at this guy. The limit as h approaches 0 of 2 over 3 plus h minus 2 over 3 all over h. I'm telling you this is a derivative at x equals blank. Derivative of some function f at x equals blank. And I wanted you to tell me, hey, f of x equals blank and x equals blank. How would we go about deconstructing this backwards? Lalo, any idea what you're thinking about to start?
Well, we know that like the first term in the numerator is f of c plus h.
I love it. So it's like, hey, I know that this 2 plus 3 over h has got to be f of c plus h, doesn't it? Okay. John, you've got your hand up. What are you thinking? John, I see your hand. Do you have a question? And then, of course, we have over h. H approaches 0. Okay, thank you, Sammy. Appreciate it. What on earth could be f for this to all work out?
Two x.
2x?
2
Okay.
over x?
2 over x? Let's try it. If that were true, this is sort of a guess, then we would have our first term would be 2 over what? What normally goes in the place of the x in our equation?
3.
Would it be 3?
Okay, it might be 3, but first it's x plus h, isn't it? Like that's the most basic thing. Minus 2 over x all over h. That would be kind of its basic form before we let x equal a number. Now let's let x equal that number you guys are thinking. What do you think that number should be for x?
3.
Okay, let's see if it works. If I were to plug in 3 here and 3 here, does that give us what we started with? Are these the entirely same thing?
Yeah.
They sure are. So that means it was in fact 2 over x was our function, and x equals 3 was the value we wanted to find the derivative at.
I have a question, sir.
Yes, I love it.
So
Questions?
how come the h for 2 over 3 plus h, like why is it on the denominator?
Because if I had had something else, like cosine of x would be my function, then when I set up the difference quotient or my limit definition, I'm going to have cosine of x plus h minus cosine of x all over h. Wherever the x goes, that's where the plus h is going to go. And since the x was in the denominator, then that's where the x plus h had to go in my first term. Does that make sense, Peter?
Yes.
Because that's my new y coordinate. How would you find the y coordinate if we were looking at 3? Well, what we would do is we would look at the average rate of change between 3 and 3.0000000. I can go on forever. This little bit here, that's just h that I'm adding in. H is so small that I'm adding in 0.0000000 forever 1. That's what h is. So that's why it has to go in the first part of my slope.
So if the x was on the numerator, it would be the same thing?
Yes. So let's look at a different one to try to drive this home. If I have this 3x squared minus 4, that's f of x, and I want f prime of 4, what would be my derivative? The little prime This prime right here is another way to write derivative. Those all mean the same thing. I just want us to see what the limit statement would look like. Emily, can you start us off? What's our limit statement going to look like if we're taking?
Because it's like a certain numeric value, wouldn't it be like that other alternate form of the derivative we looked at in the video last night? Or would it be the same thing?
It's going to be the same thing.
Okay,
I mean,
so
we
f
could
of
treat it as the alternate, but it would be the same thing. Go ahead.
okay, so h approaches 0. The first term would have to be
You're good. Don't worry about it.
3x minus 4. Or would wait, I don't know.
So
Something with h, right? We would
Okay,
have to have
where does the h go? Where does the h go?
Plus instead of minus 4.
3x plus h. It always goes along with the x. And then, of course, I would square that. And then I'd subtract 4. That's my first term. What's my second term? Well, my second term, if this is f of x plus h, my second term is f of x. What is f of x? F of x is 3x squared minus 4. So that would go here. And what would this all be over?
H.
Now, is there anything that I can substitute in? Like, can I plug in for x?
Wouldn't you plug in 4 because that's what you're looking for?
Yes. This is telling you, hey, we want the derivative when x equals 4. So all of a sudden, that becomes a 4. That becomes a 4. And I could rewrite this as 4 plus h all squared minus 4 minus 4 squared is 16. 3 times 16, I think, is 48. Minus 4 is 44. This would be the simplified derivative using the limit definition. That's the same as f prime of 4 if f of x equals 3x squared minus 4. And so, Peter, back to your question. X is in the numerator this time, isn't it? Well, sure enough, 4 plus h is in the numerator as well, instead of in the denominator like it was in the previous problem. Now, this is what I will say about this topic. It's a 2-day topic. If you say, gosh, Mr. Heffron, I feel like I'm not where I want to be, you're like every student I've had over the past 20 years. So we need practice, okay? And the way that I want us to get our practice is going to be in this leveled practice tab. We logged into Delta Math yesterday. There are 2 practices. I think level 1 is really the right practice for everybody based on how far we got today. However, if there are some folks that really pick things up fast, from the video, there was the alternate limit definition. Level 2 uses that, and we haven't really discussed that in class yet. So this second one would be for extra credit, but don't do it until you've mastered the first one. So your only homework tonight, no video to watch, no nothing, is just, hey, this Delta Math 2.2 practice is our only homework. I'll put that in Google Classroom and I'll put it in your student page just to be consistent. But you'll do it by going into Delta Math and choosing 2.2 level 1 practice. Peter, go take your dog out. Everybody, go to your next class after unmuting and saying goodbye to everybody.
Goodbye.
Bye.
I promise we will practice
Bye.
more practice, but do your best on the Delta Math, because that'll be a great place to start. Bye, guys. Good job today.
Mr. Heffron,
Yes.
thank you for not making me feel stupid, even though I said like the wrong answer. Thank you.
You didn't say the wrong answer.
Well, I
This-
kind of did, but it's just like I don't like to get stuff wrong. So just thank you for
You're welcome.
like walking us through it.
You had the right thinking. I knew you did. I could tell.
Okay, thank you.
Good job, guys.